Example number 3, probably another easy one. Solve, and what I have is 3x to the 4th minus 48 x squared equals 0. And once again, with this one here, everything is laid out and ready for us to go. So all the terms are all on one side. We have a 0 on the right side. So once again, let's get started with the factoring. Okay? And once again, I see that through our two terms here, the GCF is going to be a 3x squared. So I am going to factor out 3x squared. And keep in mind, 3x squared means we have a factor 3 times x times x. Okay? And then here inside parentheses, I have x squared minus 60, and all equals 0. So, x squared minus 16, here it goes. I have another difference of 2 squares. 16 here can be understood as a 4 squared, so I have x squared minus 4 squared. So using the difference of 2 square formula, I can factor it as x squared minus 16 into x minus 4 times x plus 4 equals 0. And then the front factors right here would be 3 times x squared. And please, I encourage you to think of x squared as x times x. So now, once again, to solve this equation here for 0, once again, you can think about simply ignoring the constant factor, the non-zero factor over here. You can just simply ignore that factor right there. Now, you only have to worry about the x, okay, and the x minus 4, setting it equal to 0, and the x plus 4, setting it equal to 0. Those are the ones that you need to worry about now. And keep in mind, the x squared right here is actually, you can have another one, x equals 0 and x equals 0. And these two together give you identical solutions, x equals 0. So you only need to count it once. With that second equation right here, adding 4 to both sides, that gives you x equals 4. Okay, and this next one, subtract 4 from both sides, gives you x equals negative 4. So once again, for this equation, we end up with 3 separate solutions. Let's now look at example number 4. So, I'm getting tired of using the x. So why don't we solve for y? I'm going to use the letter y as the variable to solve for this time. So my equation appears to be 9y cubed plus 8 equals 4y plus 18x squared. I mean 18y squared. Sorry. Okay, so there's a y squared. So this time we're solving for y. We're at some point, maybe if you're feeling tired of using the x variable all over, then we can start switching over and using the y value. Right? And so we would like to find out what the y value here satisfies the equation. So once again, we need to move all the terms. We need to bring all the terms to one side. So what I can do, subtracting 4y from both sides, and subtracting 18y squared from both sides. And that is going to leave me 9y cubed minus 18y squared. And you can see that I intentionally writing the powers of the y in decreasing order. Minus 4y plus 8. And what remains on the right hand side? 0. And once again, at this point, that's how we can turn our equation here into a polynomial looking form. And here with this polynomial, the only access we have remaining for us here is to factor the polynomial. And once again, factoring by grouping is the only choice for this problem. So the first two terms, you can factor that, you can group that into one group. And keep in mind, for the grouping part, you just simply group them precisely the way it is, including signs. So do not worry about anything else. Just don't worry about what about signs and all. Bring the signs together with all the terms. So I have 9y cubed, positive sign, minus 18y squared, all that together. Now my second group, create for yourself a group in signs, okay? And then minus 4y plus 8. That's how you group it. And now what exists in between the two groups? What connects the two groups? Plus. And then equals 0. The first group now, it's time to start factoring out each group. it's time to start pulling out a GCF from each group. The first group, I recognize the GCF here is a 9y squared, so I'm going to pull out 9y squared with positive signs, so that leaves me behind y minus 2 is my remaining terms for the first group. Now, the two terms in the second group, minus 4 is going to be my GCF. So I'm going to pull out minus 4, that gives me minus 4, and my remaining terms in the parentheses, y minus 2 once again. And then of course you no longer have to worry about the plus, because once you pull out the negative 4, it's affected together with the plus sign, and it all becomes a negative sign, equals 0. And now among the two different groups here, if you look throughout the two different groups, now you are seeing y plus 2, the part I'm underlining right now with squiggly line. That is the part where you have, that is your GCF. So now my GCF, y minus 2, I'm pulling it out. My remaining term is going to be 9y squared minus 4, all that equals 0. And one more time, the 9y squared minus 4, I am recognizing that as a perfect square, the difference of two squares. So I have my first factor. The difference of two squared here is going to turn that into 3y minus 2 times 3y plus 2 equals 0. Okay. So now, as far as this point where I have finished factoring all my polynomial, and here all I have to do is just set each factor equal to 0. My second one, 3y minus 2 equals 0. 3y plus 2, setting it equal to 0. So I have once again produced for myself 3 sub-equations, okay, ready to solve. Now to solve for it, add 2 to both sides. That gives me y equals 2. That's one of them. This one here, adding 2 to both sides, gives me 3y equals 2. And we have to divide both sides by 3. That y equals 2/3. That's my second solution. The last equation, subtracting 2 from both sides, that leaves me 3y equals negative 2, and dividing both sides by 3, that leaves me y equals negative 2/3. So once again, here you have your 3 solutions to that equation. So, example number 5. One last example for all of this polynomial equation. So, let's go back to the x. Okay? We want to solve for x. So, we have 2x to the 4th equals 16x. Once again, in this problem, what I'm seeing here is I have all my terms throughout all the sides here. It's scattered all throughout the two sides. So, I need to bring the terms all to one side. Subtracting 16x. Be what I need to start out with. And that leaves me 2x to the 4th minus 16x equals 0. And once again, we've had about 5 examples, and including with those examples we've had in other types of equations. You can see that bringing all the terms to one side is one of the crucial point here. It helps a lot of problems. Now in this problem, how can we factor this problem? Now what I can see here is the GCF is a 2x. So I'm going to factor out 2x, and notice 2x means 2 times x, by the way. So what I have remains in parentheses is going to be x cubed minus 1 equals 0. And at this point, once again, the whole goal here is we need to completely factor. And so x cubed minus 1 can be understood as a difference of 2 cubes. So you can factor x cubed minus 1 as x minus 1 times x squared minus plus x plus 1. And then the other factor, 2 times x in front. All equals 0. And so at this point, this one here can't solve. Okay? Can't factor further. Okay, so we're gonna ignore that part right here because that one we can't factor further, so we can't solve that one. That's the only little part that you ever gonna have to remember. Now, these two, once again, the constant factor, the non-zero factor, you're gonna ignore that. So all you have to do is be concerned about the first factor, the first the first variable factor. So we have the x setting it equal to 0. The next one, x minus 1, setting it equal to 0. So now in this case here, we only produce for ourselves two sub-equations. So here, x equals 0 is one of your solutions, and the next one here, x equals 1. Okay. What we have done, adding 1 to both sides. That's how we solve this one. So now in this problem, you're probably not going to see a problem like this that oftenly, but whenever, keep in mind one thing, whenever you run into the difference of 2 cubed, and after you factor it out, only the linear factor is the one that you can actually set it equal to 0 and solve. The other part, you can always leave it the same way it is. You can always ignore that part. Like that. So this is one little thing that I hope you can pick up. Otherwise, not that often you're going to see these type of equations.